we can continue until this is done.
Our tradition began long ago. But unlike most traditions, ours was one of breaking from convention. A tradition of challenging. A tradition of reimagining. A tradition of creating knowledge. While some look for what's possible, our approach is a little more unconventional. We can't say we're doing the impossible. We're just unsure where possibility ends. Our work has transformed the way we feed a growing population. Advanced breakthroughs in disease treatments, and created a generation of leaders. For over 100 years, we have reimagined and revolutionized. We have been on a mission to improve the world. For over 100 years and into the 100 next, we will continue to question, to challenge, to innovate, because it is our tradition. Our tradition began long ago. But unlike most traditions, ours was one of breaking from convention. A tradition of challenging. A tradition of reimagining. A tradition of creating knowledge. While some look for what's possible, our approach is a little more unconventional. We can't say we're doing the impossible. We're just unsure where possibility ends. Our work has transformed the way we feed a growing population. Advanced breakthroughs in disease treatments, and created a generation of leaders. For over 100 years, we have reimagined and revolutionized. We have been on a mission to improve the world. For over 100 years and into the 100 next, we will continue to question, to challenge, to innovate, because it is our tradition.
Hello, everybody. I'm honored to open the Kaye Award ceremony. This is an unusual way to have this ceremony. Usually we have this as part of the Board of Governors, but given the Corona pandemic, we are treating everything differently this year. But I'm sure this would be a nice ceremony, and it will honor the recipients and give tribute to all the great applied research that is being done here. I would like to welcome Isaac and Myrna Kaye. Where are you? Somewhere over there. The chair of the Board of Governors, Dan Schlesinger, the President, Asher Cohen, and Director, Barak Medina, and other dignitaries in here. I would like to start by asking the chair of the board, Dan Schlesinger, to say a few words. He's joining us on Zoom from Chicago, right, Dan?
Yes. Can you hear me, Ram?
Can we hear Dan? Dan, try again.
Yes, can you hear me?
We hear you barely.
Um,
The problem is with us. It's not with you, Dan. We'll fix it in a second.
okay, shall I start?
The English friends hear you very well, Dan.
My voice carries to England, but not to Israel.
Yeah, we can hear you clearly.
Actually, to Israel, you're very well received here.
Ah, it's only to Har Tafim I can't reach.
And we hear you very well.
Yes.
You can start. We can hear you very well.
Okay, thank you. Welcome everyone. As Rem mentioned, normally this ceremony would be part of the Board of Governors meeting. And our tradition in the last few years has been to recognize the 100th anniversary of the Hebrew University at the Board of Governors meetings. So that is a 7-year stretch from 1918, when the cornerstone was laid, till 1925, when the doors of the university first opened. And 2 years ago, we recognized the 100th anniversary of the laying of the cornerstone on Mount Scopus. Today, I'd like to just start off with a quick recap of what was happening 100 years ago today in Israel, in Palestine, in 1920. World War I had just ended, and the San Remo Conference confirmed that Great Britain would be the mandatory authority in Palestine. A man named Eliezer ben Pinchas Shmuel, better known as Herbert Samuel, was appointed as the first High Commissioner of Palestine, a very important event because it linked the Balfour Declaration from 3 years previous to the mandatory authority, and confirmed that Samuel, a Zionist and a Jew, would be the commissioner, which confirmed Great Britain's commitment to the establishment of the Jewish homeland in Palestine. The Asefat HaNivcharim, the Assembly of Representatives, was established in Palestine, in the Yishuv, as the first parliament of the Jewish people, and remained as the parliament of the Jewish people until 29 years later, the Knesset was established. In 1920, the Haganah was formally established as the defense force against the riots that had been plaguing the Jewish people. And the Histadrut was established as the force to protect the labor in Palestine, which went on to become a major force in the creation of the State of Israel. At Hebrew University in particular, the construction on Har HaTzofim continued, and the fundraising to solidify the creation of the University of the Jewish People continued as well. I would note that that was an important reinforcement of the legacy of Albert Einstein, which we also recognize as part of our centennial. What Einstein brought to the formation of the Hebrew University was an unusual combination of commitment to science and to philanthropy. And that combination was instrumental in feeding both the intellectual soul of the university and feeding the financial needs of the university. I emphasize that because here today, I think there's no better illustration of the legacy of Albert Einstein than the Kaye family. Their decades of commitment to the financial and scientific well-being of our university has been inspirational and transformative. So I want to personally and on behalf of the Board of Governors express our very great appreciation to Isaac and Myrna and the Kaye family. Their commitment has been fantastic, and there's no better demonstration of that than the brilliance of the scientists that we recognize here today. So thank you to the Kayes. Thanks to all of you for your support and for being with us today.
Thank you very much, Dan. I would like now to ask the President, Professor Asher Cohen, to say a few words.
Thank you very much. Let me just acknowledge the presence of a few people here: the Chancellor, Professor Menachem Ben-Sasson, Director, Professor Barak Medina, Director General, Mr. Ishai Frankel. Yossi Gal is somewhere in here. Oh, hello, Yossi. Our Vice President for External Relations, Itzi Goldwasser, the CEO of ISUM, and many other dignitaries here. I noticed Buji Herzog is watching us from afar. Hello, Buji. Many of you may know that Buji is a dear friend of Isaac and Myrna Kaye. So it's really a pleasure to see you. One of these days you'll visit us.
Here, I'm in Jerusalem.
So far, so good. I noticed that Nigel Solomon is here with a haircut. Nigel, is that it? All right. And of course, the incomparable Isaac and Myrna Kaye, that our dear friends. It's such a joy to see the two of you looking so good in your house. I know these days are not easy days to be so isolated, but you look great. And I'm happy to see you as you are. As you know, we use the term tradition of innovation for the Hebrew University for many good reasons. Among other things, ISUM, our tech transfer company, is the very first tech transfer company in the world for universities. It's second in Israel, but it's the very first in the world among universities. And it only simplifies and signifies the importance of innovation at our university, a tradition that continues to this day. It continues so much so that in, I think, a week or 2 weeks from now, we are going to start the huge innovation center in our campus, in the Safra campus. And all this is related to Isaac Kaye and his support for the Hebrew University, because Isaac has always been about innovation, about applied research, about trying to innovate and then commercialize things. He did it in his own life. He helped us doing it in all of our activities here. And the Kaye Innovation Prize is a central event, both at the Board of Governors, but in general, it's a central event. So even though we couldn't really do our Board of Governors as usual, it's very important that we do that. And it's an important time to say to Isaac and Myrna again, thank you. Thank you for what you are. Thank you for what you did. Thank you for what you are going to continue to do. Thank you for your friendship. And I'm looking forward to the continuation of this event.
Thank you very much, Professor Cohen. I would like to add to these words a few things. It was Isaac's idea that this ceremony must be conducted despite the corona pandemic. And it is this spirit with which we push the university forward, even in these troubled times. And I can tell you that the research at the university, because of efforts like yours, Isaac, and others, is continuing and is actually doing well in this time. The corona pandemic has highlighted how much science is important for our everyday life. Our fundraising is doing well because of that too. And maybe 10% of the researchers at the Hebrew University are doing research that is related now to the COVID-19 pandemic. So it is troubled times, but it is also inspiring times for the university. I would like now to invite Mr. Nigel Salomon to say, to give a brief history of the Kaye Award. Thank you. Nigel.
Thank you, and good afternoon, everybody from rainy London. Chairman of the Executive of the Jewish Agency, Mount Yitzchak Herzog, Hebrew University President, Professor Cohen, Professor Savi, University leadership, and dear friends from Israel and afar, and most importantly, our dear prize winners. And if I may also especially greet somebody who marks a birthday this week, the life president of the British Friends Women's Group, Stella Lucas, who this week marks her 104th birthday. So Stella could have been president both at the cornerstone laying ceremony and at the opening ceremony. So Isaac has asked me to speak on his behalf, and I'm delighted to do so. Isaac and Myrna's family can proudly count 3 generations and some 70 years personal connection to the Hebrew University, witnessing with enormous pleasure the astonishing developments of this great institution, whose global stature today simply would have been unimaginable when those cornerstones were laid over 100 years ago. The Kaye Innovation Awards, now in their 27th year, along with the Kaye Einstein Fellowships, reflect the family's deep commitment to the Hebrew University. They focus on innovation, and we aim to invest in people with the capacity to make real breakthroughs in their research, benefiting the Hebrew University and the broader community beyond. We see them motivated to remain here with generous 3-year scholarships, and in many cases going on to become Kaye Prize winners. I think the results speak for themselves, and I'm continually impressed by our university's achievement securing coveted European Research Council competitive grants at a level close to that of Oxford and Cambridge universities. And year on year, we are struck by the quality and merit of the winners. This year, they hail from a wide variety of fields. What is striking is how they address seemingly intractable challenges relating this year, for example, to food and nutrition, to human health and pharmacology. The component, of course, that connects them all is innovation, as in the medical application of cannabis and its associated delivery systems, proving demonstrable curative properties, yet with none of the addictive downsides. We have enormous faith in you because you truly represent the ideals of our university's most illustrious founder, Albert Einstein. He was someone who saw the world of science and learning without boundaries, and the Hebrew University as the very embodiment of that aspiration. When I think of our prize winners, it's clear that investment in our faculty, our researchers and students is of the utmost importance for both the Hebrew University's competitiveness and its global impact. We earnestly encourage other donors to support our efforts and join in with further funding for this enterprise of nurturing and retaining talent, which will serve to spur yet further innovation. The opening lines of Charles Dickens' A Tale of Two Cities come to mind. It was the best of times, it was the worst of times. It was the age of wisdom, it was the age of foolishness. And if during this dreadful global epidemic, we too are to try to find some wisdom, we need look no further than to the extraordinary research and innovation taking place daily at the Hebrew University. And may we all, through our joint efforts, help the Hebrew University look forward to a successful and ever brighter future, extending our collaboration and know-how, not only with our neighbors, but also beyond to the nations of the world. Thank you.
Thank you very much, Nigel. We're now ready for the awards themselves. And I would like to start with the first prize in the research category, which will be awarded to Professor Amos Nusinovich. I invite you, Amos, to come and get the certificate from Itzik Goldwasser, the CEO of ISUM. Itzik, I guess this is the first year that you are giving this, and I wish you many more years to come. The award is given for the development of edible protective films that extend the harvest shelf life of fresh produce, fruits and vegetables. I would like now to ask Amos to give a short presentation. Please keep it short. And if you have questions, either here, just raise your hands, or if you're watching it over Zoom, click on the raise your hand button, and we will have the questions at the end of the presentation by Amos. Amos, please.
Shalom. President of the Hebrew University, Professor Asher Cohen, Professor Barak Medina, Rector of the Hebrew University, VP of Research and Development, Professor Sari, Mr. Dan Schlesinger, Chairman of the Board of Governors, Isaac and Maina Kaye, Dr. Itzik Goldwasser, CEO of ISUM, prizes, winners and awardees, participants in Israel and abroad, good afternoon. I'm honored, happy, and very grateful to the committee of the Kaye Innovation Award for their support of my research in the field of edible films and coatings. This research has been conducted in my lab at the R.H. Smith Faculty of Agriculture for the past 30 years. Over the years, numerous research students, colleagues, lab technicians, lab managers, members of the Interdisciplinary Center and the Nano Center, librarians, and many others helped me accomplish these achievements. And I would like to take this time to extend my thanks to each and every one of them for their hard work and assistance in these projects. As you may know, at least 35% of the fresh fruit and vegetables produced worldwide go to waste due to spoilage. Our studies came about to help battle food waste in an eco-friendly way. During 30 years of research, we created formulations, designed methodologies, and developed technologies to extend the shelf life of fruits and vegetables, both as a whole and in cut form, and help reduce the use of plastics. All our formulations are based on FDA-approved, generally recognized as safe, non-toxic, edible, biodegradable materials and protected by several Hebrew University patents with the commercial potential to benefit both the university and society. Our first family of coatings is referred to as emulsion coatings, demonstrated here on peppers. Pepper is a hollow fruit with a limited water reserve. Left for a few days at ambient temperatures, water loss occurs through respiration and transpiration, causing the pepper to wrinkle. This limits export, especially when transport conditions are not closely monitored. Our first innovation was to create an emulsion formulation for coating that blocks water evaporation and eliminates fermentation. This was done using a purposely imperfect coating that includes chaotic disturbances in the structure of the coating layer. The coating is 20 microns thick, transparent and glossy, and keeps the crunchiness and taste of the fresh fruit while extending the shelf life for weeks. The second family of coatings, known as film coatings, was invented to eliminate the opening close of garlic bulb. They also apply to onions, flower bulbs, peanuts, and others. Based on the idea, it is possible to create a film paper-like coating that tightens around the bulb to prevent it from splitting, while acting as an individual form of packaging, eliminating the use of plastic for this purpose. Applying the coating increased net weight by more than 10%, and prevented insect attacks, important for both home use and planting. Our third family of coating, labeled bandages, deals with the particularly processed foods. In pomegranate, for example, 10–20% of the aril suffer from cuts. Once processed, fluids exuding from the cuts deteriorate the microbial state, limit shelf life to only 4 to 5 days. By introducing a medicinal approach, our formulations and respective methodology and technology seal only the damaged part of the aril, decreasing fluid outflow from the wound and improving its microbial counts, extending its shelf life to almost 2 weeks. The same idea also be applied to single grapes, cut, tree trunks of trees, and other such products. We are currently working on coatings designed to replace plastic packaging for cucumbers and others, applying to peeled, cubed, and chilled mangoes, pineapples, and other tropical fruit, as well as several patents, formulations, industrial experiments in Israel, Europe, and North America, and founding a startup company, Sufresca, to help make our invention.
Thank you. Okay. I would like to invite now Professor Elka Twito from the School of Pharmacy for her breakthrough technology of delivery system for pharmaceutical cannabinoids products. Elka, please receive the award from Dr. Goldwasser. Okay, please say a few words.
I'll be short. Distinguished audience, I'm very excited. This is the second time that I receive Kaye Award for my work and innovations. And I would like today to a few words about the last innovative technologies we have designed with my group in my lab. Cannabis. Cannabis is known today as a very usable and also very promising to make a lot of money in a field that we don't know exactly how to deal with. As per today, what people receive are very simple, I will tell primitive formulations with the molecule from cannabis, the cannabinoids. In this way, no control, no reproducibility, and the effects are not the best that could be achieved. What we have found, or I have found in fact, is that by combining the molecules from cannabis with the natural amphiphilic molecule, we can get what is called a physical interaction that we can use it very simply, in fact, but we can use it to modulate, to get a number of delivery systems to be administered by different routes of our body. So, in fact, we have been successful to get an oral, what we call an oral tank with the cannabinoid that we can have a prolonged analgesic action for 10 or 12 hours. As per today, the action is around 4 hours and no more. Using the same, but modulating the same combination, we can deliver nasally the cannabinoid, which arrives to the brain for treatment with many CNS ailments. Another application that we have is applying the innovative technology to the skin, and there we can modulate either to use the cannabinoid for dermal problems or to have it absorbed systemically for what we call the transdermal applications. So in fact, we will have here the possibility to design, and we have designed. We are today at the stage of having final formulations. This is why you see all this packaging for the various delivery routes. For the oral, in the oral, this tongue, which in fact is eroded for many hours, or for nasal by just applying drops in the nose to get to the brain, or for dermal, transdermal, and the other pathways in the body. So we think that this technology, which is again made with what we call grass, is generally recognized as safe material. We have the opportunity to give to the industry the possibility to have a portfolio to develop many products. Thank you.
Thank you very much. Does anybody here or in the audience have questions for Elka? Barak, was that a question? No? Questions? Or for Amos, the previous speaker, the first award recipients? Questions? I know it's difficult to have these questions over the Zoom, but let's take the photo with Elka. Congratulations again. And I would like now to mention Professor Galili, who is the third recipient of this award. She's unable to attend in person. Is she connected over the Zoom? She received
I am here.
You are here. Where are you? We'll
in
find
Street in Jerusalem, in Nayot area.
Here you are. Okay.
Yeah.
Perfect. So Professor Galili is receiving her award for the discovery that CBD, and again cannabinoids, is a powerful anti-inflammatory and is useful for treating diabetes and obesity. Ruth, would you like to say a few words?
Yes, of course. In the last 20 years, I have been studying quite extensively the properties of cannabidiol, CBD, one of the two major components of cannabis that is without psychotropic effects meaning it does not affect mental activity, mood, and perception. Although this molecule has been studied for years, we really concentrated in, as immunologists, in various autoimmune diseases and its effect. Its CBD is a very pronounced inflammatory and antioxidative activities obtained through a number of different mechanisms. And I have demonstrated it that in animal models, it has a remarkable effectiveness of the molecule in various pathological conditions, such as rheumatoid arthritis, multiple sclerosis, and diabetes type 1 and type 2. In this animal model, we really achieve the curing of the tested animal, and its activity in various animal model was even better than the usual drug. Furthermore, recently I have focused in CBD, which have, however, with all its effectiveness, very narrow effective dose effect, a bell-shaped one. This capacity, of course, will narrow its being treated as a drug in the animal and in the human autoimmune diseases. In addition, I realized that CBD is a natural occurring compound and it cannot be patented in the drug company. It cannot be patented by Zoom. Thus, in the last year, I have started testing synthetic molecules that mimic CBD property and synthesized by Professor Meshulam. These molecules were shown to be really very active in treating and curing 4 autoimmune diseases in mice: the MS, rheumatoid arthritis, and the diabetes type 1. In all these animal models, we indeed demonstrated that the effectiveness in curing these mice. And we were very much, we have shown it very clearly. However, some of the molecules have a bell-shaped dose response activity, meaning in high and low dose, it is only have limited one. So we ask our friend, Meshulam, to synthesize new molecule. And indeed, we have observed that some of the molecules mimic the cannabidiol property, and their capacity also to be useful in the mice model of 3 autoimmune diseases: rheumatoid arthritis, MS, and diabetes type 1, and recently also type 2 animal model. In all these animal tests, we really demonstrated effectiveness. And I hope that we will find, in addition, new molecules that will be even more active than the cannabidiol, and we can be patented and being effective also in human diseases. The model in which we demonstrate in animal be applicable to human patients. Thank you.
Thank you very much, Professor Galili. This is again an opportunity to ask questions to either Professor Galili or the previous two awardees. I would like to ask Amos, how do you choose which vegetables or fruits deserve your coating?
We are looking at, in fact, there are several stories related to our decision what to do in the next research. First, as far as for garlic, when you go to the market, nobody will buy a garlic bulb which its clothes are splitting. So we asked ourselves whether we are able actually to eliminate this problem. And this was done by inventing a paper-like material which actually tightened on the bulb and eliminates the splitting of the bulb and serves as a package. For the pepper, I was working with Dr. Yoni Elkind, who is chief genetist of pepper, and he asked me whether I'm able, he told me if you can solve this issue, if you can solve this problem, maybe peppers from the Arava will be able to reach the United States of America because in Christmas time, first it takes about 3 weeks to reach the United States, or even if you are exporting peppers from Mexico to Israel, it takes time. Pepper is a very sensitive food, so we are looking for some sensitive foods and big problems. And in this case, because the water reservoir of pepper is so small, we have to find a way, and this is quite delicate, we have to find a way how to coat it on one hand, but if you coat it too good, then it suffers from fermentation. So what we found is that if you are able to include water-soluble polymers within the formulation of the pepper, it gives option to both a nice passage of the water vapor or some or oxygen or carbon dioxide to inside and outside from the pepper on one hand. And so this coating in a way eliminates the option of fermentation. And by the way, this is indeed very interesting because the first coating was invented in China 900 or 800 years ago, and actually they covered oranges with paraffin wax, and after it looks fantastic, but after 2 or 3 days it suffers from fermentation. So actually by solving the problem of the pepper, we solved a very kind of ancient problem that the Chinese couldn't deal with. Now, as for pomegranate, this is indeed a very nice. This is a very nice invention because we treated only wounds on the pomegranate reels. This is really a problem because when you coat something in a hole. But this time we found a way to treat only wounds or cuts on surface of a fruit. I believe this is quite unique. So to conclude, we are looking for big problems, and after doing some deep survey and literature research, always find some, I would say, outstanding ideas to solve these issues. Okay?
Thank you very much.
Yeah.
Then there is the question of
There is a question. Who?
Is directed to it. Is nanotechnology being developed by innovation? Let's talk about innovation.
Do you want to answer or?
Yeah. What was the question, please?
Established under a innovation fund.
Yes. Actually, actually agri innovation under ISUM actually invested in our startup. I would say 4 years ago, and about half a year ago, Rimonim, the VC Rimonim, actually invested and founded Supresca to continue with these efforts.
Thank you.
Okay.
Thank you again. So as some of you know, I'm doing research on astrophysics, and in one of my papers, I was very proud that I extended some concept of Lagrange from 300 years ago. But now I see that Amos is taking some Chinese thing from 800 years ago, so what can I do? Okay, now we are going for the second part of the ceremony with 2 student awards. In the Kaye Prize, we have a category for established researchers, which you've just seen. And now we're moving to the young researchers, which hopefully in some years will come here again as the advanced researchers. And the first prize is given to the student Orit Berhani, which will now receive the prize from Dr. Goldwasser. Orit's work is on immunotherapy involving killer cells, natural killer cells. Orit.
First off, I would like to say thank you to the Kaye Innovation Award Committee and obviously to all the distinguished guests here on Zoom, and especially to the Kaye family. Thank you very, very much for this, for honoring my work with this very prestigious prize. So briefly, sorry, camera, yes. My work is in Professor Opa Mandelbaum's lab. And we focus on a unique immune cell called natural killer cells. These cells roam our body in search for deleterious cells or harmful agents, including virally infected cells, bacteria, fungi, and most importantly, cancer cells. So over the years, it's been shown that when natural killer cells come in contact with a cancer cell, they swiftly and efficiently destroy them. However, these studies are usually done when we take the natural killer cells outside of the body and into the lab. So what happens in our body? The immune cells, the natural killer cells, make up about 10%, and they travel throughout our bloodstream really, really quickly. So they may end up missing a cancer cell or two. So we thought, how can we help the natural killer cells recognize a cancer cell more efficiently? So for that, we're developing bi- or tri-specific antibodies, which will strongly bind and tether the natural killer cell to the cancer cell. Antibodies are very specific against their targets, and they maintain a very strong hold on them. Therefore, they will grasp the natural killer cell with one arm, and they do that by recognizing a very specific marker on natural killer cells. And the other arm, they will recognize a specific marker on cancer cells. This will then bring the two cells into close contact and enable the natural killer cell to destroy the cancer cell. Therefore, this would lead to targeted and highly efficient elimination of cancer cells. Thank you very much. Picture or?
Picture and then questions if there are any. So let's go for a picture first. Thank you, Orit. Let's see if there are any questions. Any questions for Orit? Ishai.
Does it work for viruses as well?
Good question. We haven't checked that yet. It's definitely something that we would, that's definitely something that we would explore as well. Because the important thing is to first tether the natural killer cell, and then the whole world is open. We can try and target cancer cells, virally infected cells, bacteria, fungi, anything that would be specific. Okay.
Any other question? Is there a question on the Zoom? Can someone tell me if there is anything? No. Thank you, Ori.
Thank you very much.
Congratulations again. Our last awardee could not attend in person again because he's in the US, stuck in the US, I guess. No flights. Amichai Saragovi. Can we put him on the Zoom screen? Shalom, Amichai.
Good afternoon, and
thank you. Just a second. Amichai is from the Faculty of Medicine, and he's getting the prize for his work on a novel strategy that enable T cells to exclusively utilize alternative carbon source to glucose. So, Amichai, you will get your reward later on, and we will be happy to first congratulate you. Please tell us a few words about your research.
Right. Okay. So I noticed I'm unable to share my presentation. So whoever is a host, it will be nice if by the time I'm saying thank you to all the distinguished guests and to the Kaye family for giving me the prize and supporting the whole event. Again, thank you. So unfortunately, it seems that I'm unable to present my oh, okay. So someone did it for me. Okay, great. So like Orit mentioned, immunotherapy holds a great promise to cure cancer, many different types of malignancies, and it became kind of a buzzword nowadays, and there are like startups and research groups working on T-cell therapy and NK therapy all over the world. Now, a challenge, or perhaps one of the biggest challenges underlining all these therapies and all these treatments is basically the metabolic suppression induced by the tumor, and specifically solid tumor, when the cells are approaching the cancer to kill it. Put it simply, you can put as much weapons and sensors on your car. If you don't have fuel in the car is not going anywhere. And this is kind of the problem that is now established as a major challenge to immunotherapy. So how do we know it's a problem? Because we actually use glucose labeling to find cancer when we are screening patients. So as you can see in the slide, in red, in the case of glioblastoma, the cancer is simply sucking all the sugar, all the energy source from the environment and making the T cell unfunctional, and the rest of immune cells as well. And other experiments we did in the lab and other labs as well demonstrated that T cells and NK cells and basically any other immune cells is unable to function and deliver its typical death blow to the cancer cells because of lack of glucose or energy source. So our solution to this problem, we kind of try to come up with a generic solution as we are working in a field called immunometabolism. Basically, we try to understand the metabolism of immune cells. So we thought, what if we take a metabolic pathway, a whole pathway from nature that we don't have, our genes don't hold this information, and we kind of give it as a present to our T cells, our immune cells. Then these T cells, these immune cells, will be able to consume an alternative fuel source that the cancer cannot use. In this way, the immune cells will have available fuel in all parts of the body, including deep inside the malignant tissue. So as you can see in the middle of my slide, the idea is to first engineer the T cells or the NK cells or any other killing immune cells used in immunotherapy, and then deliver it to the patient in parallel to injection of our alternative sugar that is exclusive only to the immune cells, and in this way allow the T cells to eliminate the cancer. So what we did so far, we were able to constitute these genes. This is a whole metabolic pathway that we had to reconstitute in the immune cells, in human mammalian cells. And we were surprised to see that it actually worked and that the cells were able to survive and proliferate and perform miraculously. This is kind of normal metabolism. This is a bottom part of the slide. Despite the fact that we depleted the medium completely from the major carbon source, glucose. So the next steps now in the lab of Micha Berger, by the way, I forgot to mention an important name. So the main steps are now to take these T cells and to examine the killing potential in a zero glucose environment, and also inside in vivo, inside animal models, and hopefully one day in as a therapy for patients. That's it. Thank you very much.
Thank you very much, Amichai. Do we have any questions here or on the Zoom? Okay, thank you very much. This will conclude our ceremony. I would like to take this opportunity to once again thank the Isaac and Mirna Kaye for the wonderful support over the years and for pushing us with these prizes and with other donations to go on with our research and do the great things that we want and can do. Thank you very, very, very much. And this is the end. Thank you, everybody.